Welcome back. In this video, we'll learn about Shilliot algorithm. Why we use this Shilliot algorithm? First, we'll look into this. One of the fundamental steps of an unsupervised learning algorithm is to determine the number of clusters into which the data may be clustered together. The Shilliot algorithm is one of the many algorithms to determine the optimal number of clusters for an unsupervised learning technique. In this algorithm, we make an assumption that the data has been already clustered into k clusters by using any clustering technique. Typically, it may be k-means clustering algorithm. So first we'll learn about the concept of Shilliot algorithm. The Shilliot method measures how similar is an object to its own cluster, that is the cohesion, compared to other clusters, that is the separation. So this gives a Shilliot score for each data point. How to calculate this? For each data point, we will be calculating the Shilliot score Si, which is equal to B of I minus A of I divided by maximum of A of I and B of I. We'll see what is A of I and B of I. A of I is average distance between I and all other data points in the same cluster. That is said to be intra-cluster distance. Okay, and now B of I. What is B of I? It is the minimum average distance from I to all data points in other clusters. Okay, so this is also called as nearest cluster distance. What is the nearest cluster distance? We'll see this with an example. Consider a data point I. We need to calculate A of I. So what is A of I? I is a data point and we are going to calculate A of I. What is A of I? A of I is nothing but the average distance between I and all of the other data points in its own cluster. So we need to find what is the distance between I and this data point, and we will be calculating the distance between I and the second data point. I is also a data point. We'll find the distance between these two data points, and we'll be taking the average of all the three values. That is said to be A of I. A of I is nothing but the average distance between I and all of the other points in its own cluster. These are all belong to the same cluster. Now we'll calculate what is B of I. B of I is nothing but the distance between I. I is in cluster, this cluster, first cluster. I is in cluster 1. And from this cluster, we are going to calculate with some other cluster. This is another cluster. Okay. The distance between I and its next nearest cluster center. Okay. So that is said to be B of I. So now we'll calculate the distance between I and the another data point, I and the second cluster center, I and the third cluster center. So we'll be calculating all these values and then we'll be calculating the average of it. So this is said to be B of I. And now S of I is, for this particular data point, S of I is equal to B of I, the calculated B of I value minus A of I value divided by maximum of A of I and B of I. This value can range between minus 1 to 1. This value can range between minus 1 to 1. So what is the meaning if we are getting the value as minus 1? It means that sprawling. Sprawling is nothing but overlapped cluster. This data point is in overlap with some other cluster. Okay. If it is a value is 1, it means tight. It means that it is a well separated cluster. Okay. It's in a well separated cluster. After calculating S of I for each and every data points, then we need to calculate the average Shilliot score. What is an average Shillard score? Average Shillard score will be calculating as S is equal to 1 divided by N, summation of I equal to 1 to N S of I. Okay, we'll get a value. So this value can range between -1 to 1. If S is close to 1, then it means that good, and it is a well separated cluster. Okay, we are calculating the average Shillard score. This is for all the data points. We'll be calculating all the data points in a particular cluster. Okay, and then S near to 0, if it is nearing to 0 or is equal to 0, then it means that it is overlapping cluster. If S is nearing to -1, then it means that it is very poor cluster. Okay, based on this average Shillard score only, we will be coming to this point. And now, by using this average Shillard score, what we will be doing? We'll be able to choose the optimal number of clusters K. Okay, we'll be able to choose the optimal number of clusters K. How we'll be able to do? By computing the Shillard scores of different K values. So, for example, you can do from K is equal to 1 to 10, and then from these different K values, we'll be picking the one with which is having the highest average score. So, for example, 3 is having the average Shillard score as high value, then that we'll be selecting as, for this particular example, we'll be selecting 3 number of clusters. So, that's how we use the Shillard score to find the optimal number of clusters for the given data points. Thank you.